Hello, this is Chad Williams, and I'm going to run you through Lab 8 chi-squared tests. This is your last lab of Psych 300B, so congratulations on getting through all of it. As usual, we're going to set our working directory. I'm going to use the drop down, but you could use whatever you prefer. And there we go, there's my data there. And then we're going to load that data. Do note that again, this is a new data set, so make sure you're bringing in the data set that we're going to be using today. And what's different now is we have a lot of different columns with the variables all outlined as labels rather than numbers. And we have 290 observations with 9 different variables here. The next thing is that we actually don't need to install any packages today. So everything we're going to do is in base R, so it doesn't come from a library or package. So we don't need to worry about that. I'm going to walk through this demo here, but do note that all of the variables I'm going to be looking at, for example, improved life, later social media prefer, and so forth, are not what you should be looking at. So look at your assignment and make sure that you're changing these variables to match your assignment. But the process will be the same. So the first thing we want to do is create our observed values. So we're going to get our observed values for this. So if I look here, our improved life is what I'm looking at. So whether people think that social media has improved or worsened society. So if we use this table function, we can easily get these out. So here it looks like 102 people think that social media improved society, whereas 188 people think it has worsened society. Now we're going to use the chi-squared test to see if this is a significant difference or not. And that just looks like this here. And it's pretty simple. We just put our variable, our table that we just created, this here, into it. Then let's print the results. And what we see is I have a very small p-value. But more than that, we're going to look at our expected values. The chi-squared is actually showing there's a significant difference from these expected values. So we have another parameter we can add in to the chi-squared test, which we're going to do later, and I'll show you that when we get there, which is called probabilities, but it's shorthanded as p. When we leave it out here, it expects that all of our probabilities will be equal. So you see here that we think our expected counts for each of these two responses are equal, so 145 and 145. So what the chi-squared result is saying is that our observed values are not the same as our expected values. So that takes care of our first chi-squared. Now we're going to do a chi-squared goodness of fit. So here I have 4 different levels in my social media prefer. So are there differences? And again, we're not going to have a probability signified here. So we're going to see that our probabilities that are expected are equal. So I'll even outline that here. I'll rerun that in a second, but I just want to show you, we're going to be testing whether these numbers deviate. So these are observed values, whether they deviate from our expected values of everything is equal. So I'm going to rerun these 2 lines of code and see if that's any different. And we see, yes, there are differences. So no, not all social media platforms are equally preferred to each other. And again, we can print out our expected values. So what we have is we have our observed values up here, our expected values up here, and then our test here. Great. Next, we're going to do something slightly different. We're going to use the probabilities from one variable, so specifically dependent self, and I'll talk about that in a second, to see if it's any different from another variable, i.e. the dependent others. So I will first outline this here, where we're going to create a new order of columns, which is the fact that R always puts our columns in alphabetical order. So if I go back up to, let's just say, social media prefer, what we get is Facebook, Instagram, TikTok, and Twitter. So that's in alphabetical order. In that case, it doesn't really matter which order these are. It's nominal data. But sometimes it does matter because we do have some order to it. For example, we're going to see that it ranges from not at all to extremely. So how dependent you or others are on social media ranges from not at all to extremely. Now, what R is going to do is it's going to put that in alphabetical order. But it's really hard to read if it's not in the order we might be expected. So you're going to see that we're going to reorder our data here, here, and here, just so we can read it in this order. It's not too much to worry about, but just so you know what that is. So this whole thing is going to do one test of chi-squared, which is going to be comparing the responses for dependent self to dependent others. Let's first look at those responses and talk about what that means in a moment. So if I just get the dependent others, what we see is an ordinal scale on how dependent people think others are on social media. So we see that only one person thinks that others aren't dependent at all on social media, whereas lots of people think that others are moderately dependent on social media. Now we have a very similar question, but we're asking about yourself next. So how dependent are you on social media is the question. And what we see is these numbers seem to be a lot more in the lower end. So 14 people thought, well, I'm not dependent on social media at all. Whereas before, when we were talking about others, a lot of people were moderately dependent, but now it's gone down too. But the question is, are these significantly different changes in responses? What we're going to do is we're going to use this P parameter, and we're going to create a probability from this here. So we're going to turn these into a probability and say, well, does dependent others differ from these probabilities here? So we're going to create the probability right here, and we can see that. This goes back all the way to PSYC 300A when we're talking about frequency tables. So this is familiar to you. It was a while ago, but I'm not going to get into the math of how we're creating these probabilities, but you could definitely review back there. But luckily for us, we don't have to do the math because this function is doing it for us. So now these are our probabilities, and we're going to put it into our function of chi-squared as a probability table. So now we're going to see, are the dependent others variable, so that's this one up here, any different than the probabilities we'd expect from the dependent self variable? And if we run that, we see that yes, it is different. So there is a significant difference between the responses of when you're talking about dependency for others and dependency for yourself. And we can look at our expected values again, and there you are. And that goes back to be this exact same as we got in this table here. Finally, we're going to do a chi-squared contingency table where we have two different factors and we're going to compare them directly. So we're going to look at improved life to social media prefer in this demo, and make sure again to look at your assignment to make sure you're doing what's on there for yourself. So if I run these lines of code, what it does is it creates this 2x4. So this is our social media preferred. So Facebook, Instagram, TikTok, or Twitter, and then our improved life, which is that social media has improved or worsened society. And we're going to run a chi-squared test. Again, just the same kind of thing. We just input this. We're not creating our own probabilities at this point. We're just letting it be all equal again. And we're going to look at that. And we see that there is no association between these two variables. So depending on whether you think it has improved or worsened society, it does not actually determine what social media platform you would prefer, and vice versa. Finally, we can look at our expected values, and here they are. So again, up here was our observed values, and here are our expected values. Good luck, and hopefully you had a great semester, and keep it up.